Hello. Hello. Hello, students. Hello.
FM tender.
Hello.
Hello, ma'am.
We will wait for 1 minute and we will immediately start at sharp 8:31.
Yes, ma'am, sure.
Okay. So, have you given message to Rohit and I forgot the other Bhushan or something? L5 and K5, some batch member. Arna,
Yes, ma'am.
did you send the message to K5, L5 student representative as well?
Yes, ma'am, I have sent them. I've sent it on the main group of all the divisions.
Okay, fine.
Hmm.
Okay, so eventually the student will join later. Meanwhile, we will
Yes.
see whether the you will. I'm going to unmute all. Arnav, first check whether you are able to see the screen, so that we will
Yes, ma'am.
immediately we will check for it.
No, ma'am, it is not visible.
No, no, I have just not started.
Okay. Yes, ma'am, it
Are
is
you
visible.
able to see this?
Yes, ma'am.
Okay. So I wanted to check whether the screen is visible to everybody. So quickly we will start this and we will end up this with the session of GPS. We will go till the GPS programming, and meanwhile if the session interrupted, I will give you the another code immediately. Okay.
Yes, ma'am.
So let us start, because as per the timing we should start at a time. That is my strategy. Okay. Yesterday only we are late. So good evening, students. So I hope you are hear me. And today, as per the discussion we have started, we are seeing the unit number 4, and some part of the unit number 3 today I have to take, because this is the heart of all the assignments, and so I thought that let me revise this for you people. So today we will start from the UART section. So everybody, I hope that you have gone through the UART very well when you have learned this in your classes. So I'm not going with the features and everything, only the terminologies which are important for the coding perspective we will see, and then we will move immediately towards the GPS. Okay. So basically LPC 2148 contains the two UARTs. So whenever you are doing a programming, you have a facility to work with either UART 0 or the UART 1, and eventually you have to program the particular pins using pin select, and you have to use those particular SFRs. So when we are dealing with the UART section, so you should know that the which particular so you are going to use a which particular framing when you are doing the some kind of a transmission of a data. So you should know that it's a asynchronous transmission. So asynchronous framing, everybody should know the start bit, then the data, then the stop bit, and everything. So I hope this is known to you. So very important feature of the UART is this, that it is a 16-byte receive and transmit FIFO. So wherever you are going to transmit or receive the data, everything is internally managed with the FIFO. And another point which always you should remember, that it's not
हो ना
going
भैया
to transmit
म्युनिसिपल बॉडी
data register or the
टू व्हीलर
RB
का
whichever the receive buffer register is directly dealing, but it has some kind of a a shift register inside the structure that every time you have to remember. Okay, so I'm highlighting the important points as per the perspective of this particular UART internal organization. Whenever you are doing the UART 0 programming, you should know that which particular pins comes into the picture. Based on that, you have to choose your pin select register. So this is the 21 and 19 pin is there. Only two pins are important, P0.1 and P0.0. So UART1 on the similar line, the same features are there. Everybody should understand, if the external will ask you, does there is a connection between modem and normal UART, then you have to tell yes, inside it modem is also there, and these CTS, DECD, all these pins are there. Carrier detect, so then your whether that particular device is ready or not. All these are the handshaking signals between the modem. Okay, so yes, you have to tell yes, there are the modem pins, but we are not using in a programming. We are only concentrating on the RxD and the TXT. So similar line, this is for the UART1. Okay, so this is the general structure which you have to remember when you are dealing with the connection. So always we are looking with this section only. So we are going to connect this to the DB9 connector, and this is showed it over here. So this is our DB9 connector, RS232, which you have used whenever you have interface GPS. You have used this whenever you have done the coding of this your UART and everything. Okay, so I'm not going detail with the framing. I want to go through this slide. This is very important because many a time student want to understand what exactly the inside structure, and external ask you this. So whenever you are going to consider the transmit section, you should remember that whichever the data you want to transmit on the transmit data line, so it comes from the THR, then it goes to the TSR, and then it comes over here. Okay, so these are the internal shift register structure, transmit hold register. It will send it over here, then the framing and everything has been done, and then the data has been passed on this line. On similar aspect, when you are considering the UART receiver, whichever the data you are receiving, okay, so this shift register again comes into the picture, and then data will be coming into the RBR. Here deframing will be done, and the data will be come inside the LPC 2148. So this is a heart of the your transmit section and the receive section. Okay, so whenever we are going to connect the microcontroller to the UART, this connection you have to remember, and max 232 is always there. So I'm not going to deal with this max 232. Everybody had done the thorough study of it. So I'm skipping handshaking signals of the RS232 as well. So this is the interfacing diagram. So you have to remember this max 232. This is the voltage converter IC. You have to answer this technically correct. What is the use of max 232? And this is the connection with the DB9 connector. Whenever we are dealing with the UART register, everybody should remember that you are dealing with the RBR, THR, DLL divisor latch, LSB divisor latch, MSB, this LCR, line status register, line control register. Only these are the important registers. Even though I have highlighted fractional divider register, we are not using this. Later I will give you a small description about this also, but these are the main registers which we are dealing with the UART. So whenever external tell you to draw interfacing diagram, this is my sincere suggestion. Immediately you should write SFRs include in your programming, so that it will add a weightage that yes, you know the what things you are going to write, or which the SFRs you are going to use in your program. Okay, so LCR, line control register, what is the use of it? It decides the how many bit you are going to send, how many stop bits. Okay, parity and everything. Generally we are keeping everything as a 000. We want to make this PLAB bit as a 1, so that you are going to load the values in the DLL and the DLM. And a very important thing is we want to transmit the 8-bit character. Rest everything we are keeping it as a 0. So 1000, and this 00, and this is 11. So generally 83 we are loading into the LCR. This everybody knows, but how it comes, this is a general revision. Now this line status register is there, which generally deals with all kinds of error, and whenever you are writing a transmit data and the receive character or transmit character function, you are using this line status register. You are polling either THRE bit or the TEMT bit when you are writing the transmit character function, and when you are going to write a receive character function, you are polling this RX bit. Okay, so these are LSR is very important when you are going to write things, whenever we are writing the function. So you are generally checking whether the THR contains valid data or not, or whether the both THR or and TSR is empty or not. Like this we are going to check in our code or in our function which we are writing for the transmitter character, and the receive character only we are polling the this bit. So please, these are very important thing for writing the two functionality of the UART. Okay, so I have completed till over here. You are using the first thing as a initialization. In the initialization, I'm parallelly dealing with the coding aspect. We want first register pin select, second register LCR. I have completed it. Okay, then there is a calculation of the value to be loaded in the DLL and DLM. Once the value you are loading, then eventually you have to make this DLB bit as a 0. Okay, so till this everybody, I hope you have understood. Okay, then this receive buffer register is there, from where the data has to be first received, and then eventually the working on it happens internally, right? And similar line transmit hold register is there. In 8051 there was only one register, but here the two registers are there. For transmitting section this one, and for receiving section RBR. Okay, then divisor latch register, everybody knows about this. Only we will go immediately towards the calculation. Okay, so calculation is like this. So everybody should by heart this formula, PCLK divided by 16 into this value to be loaded. So we want to find this value. So eventually our formula for this type of a calculation we can rearrange, and this value is like this. So suppose we are considering the baud rate as a 9600, then this comes, you are going to convert it to the hex, and that value you are going to load into the DLL as it's only a single 0861. Fine, if it is a 16 bit, then it will come into the DLM as well. So this is a baud rate calculation. So everybody should please go through this. They will change the values and they will ask it for the 4800 baud rate, then you should able to find out this value to be loaded in the DLL and DLM. Okay, so next one is a fractional divisor. As I have told you, this is another important thing in which you can use the your add value and the mul value which is comes from the PLL. Okay, and this formula is a little bit modified like this, which will gives you more accurate result. Okay, so if you are going to use this values over there, generally this multiplication and the divisor bits are within the range 2 and the 4 only we are going to consider. And suppose this value you are getting, again the same formula, only these things have been added externally. Then if you see over here, the value comes over here it as a 9615, when eventually when we are considering as a baud rate 9600. And in other case, this difference is a more one. So to get a more closer result, the further facility has been given by using the fractional baud rate calculation. But even though you won't do this, it's okay. We have not done this in the practical, but they will ask you that there is any other method to do the calculation, then please you should elaborate this. Okay, so the next one is, eventually we will go for this. These are the different calculation which you can do, and you can tell about the difference in the error. Okay, so we generally with the fractional divisor error FDR method, it gives you a more accurate result than the without FDR. Okay, so we are not going to use this interrupt identification registers and the FIFO register, so I'm going to skip it because no one will ask you in the oral, and they will ask you in a general UART section only. So this is the UART interfacing diagram. Okay, so please you just go through the interfacing diagram once, and all this pin connection. So as I have told, pin select register is a very important, as we are using UART 0, so the pin select value will come like this. This is the initialization part which I have already told you, and this you have to by heart. Now when you are going to put character, so put character means you are going to transmit the thing, whichever character you want to transmit, it should come with the first into the THI. You are checking, as I have told you, which bit we are checking over here. Please see over here. So it's a 00. 10. So THRE. So you can do this thing with the 40 as well. Answer is the same only. Okay. So if this bit is the value is not here, then you just wait. Otherwise, you have to go to the next line. Like this, you have going to monitor whether the data is there or that particular TSR and the THR are empty or not. Like this, you are checking with this, and then eventually the data you are going to transmit. In a receive character section of the get character session, you are going to monitor the last bit of the LSR. And once the valid data is there, you are going to return it to the main program. And this is your main program where you are simply writing correct get ch, whichever the character you are transmitting, you are just giving it, receiving a character, and you are just transmitting it. So these is the very simple steps which you need to follow whenever you are writing any programming of a ADC interfacing. Result should be out on UART, or it may be a GPS, or it may be any I2C. So these four functions are very important. And additionally, when you want to out a string, we are again using out means what you are going to transmit the thing. So you are eventually transmitting a string also through the transmitter character function only. So this is the important thing which you should remember. Fine. And this is the main program. So when you are going to display the particular string, so here the string is there, welcome PICT, and you are just writing a simple logic of how many characters are there, that loop is there, and then you are going to transmit the particular string. So the next section which I want to immediately start, I guess I'm just stop sharing and I will just ask my students. So I'm unmuting all. So till this everybody understood, the students? Hello.
Yes, ma'am.
Okay, so I hope the UART section is pretty much clear to you, and everywhere whenever we are taking the reference, there is no ambiguity to understand the UART section. Okay, so immediately we will again, I'm going to share the screen and I'm going to unmute all for the next section. Okay, so before going immediately to the this, are you able to see this window?
Yes,
Yes,
ma'am.
ma'am.
Okay, so this is the program which I have given or I have showed you in the last session of the ADC. So if you see the ADC now, please revise it quickly. Whenever we are doing the ADC programming also, we require all these functions, which are those initialization of UART, okay, then your put character function or whatever, or the if you want to display ADC related string, then we want to use again the same function. Okay, and we are going to use this same ADC logic which we have yesterday discussed. We have started the start of conversion signal, we are, and if we are polling for the end of conversion, if that done bit is we are polling, and then we are eventually transmitting that particular or particular ADC values on a UART. So this is only you have to remember S printf is the function which is the new thing over here, which directly prints on your hyperterminal. Okay, so this completes the ADC section now, and then we are going towards the ADC section with UART, because yesterday I thought you might be juggling with what madam is talking about. When the UART I have not taught to you, I have directly started with the this ADC only. Okay, so I hope that now it is clear, and we will immediately move towards the GPS section. So up till now we have completed the experiment wise ADC with the UART and LCD. And another thing is ADC with interrupt, they will ask you in an oral, but as I have told my all batches, ADC with the interrupt is not there in your practical syllabus. So but they will ask you the questions regarding that, but that eventually I will touch in the next section. Okay, so the next one is the GPS. So everybody knows the GPS stands for Global Positional System, and we have interfaced it with the LPC2148. So what exactly, whenever the external takes oral over there, what exactly the external wants to know? First of all, external don't want whether you are knowing the whole GPS architecture. No, not at all. they are interested in how you are connecting a ready-made GPS module to the LPC2148, and you are pretty much understanding what exactly the role of the UART when you are connecting the particular GPS module to LPC214. Okay, and the some kinds of a format they will ask, so in which format you are receiving the data. So you have to quickly give the answer as a whichever the data we are receiving, it is of a NEMA standard. So what exactly the NEMA standard is, which are the GPGGA, if it is giving you the longitude and latitude, is any other terminology or any other string which you are knowing, which is working on a parallel line of the GPGGA. Like this, the simple question asked, but they won't ask you explain what exactly is there in the GPS module. Okay, so next task is, so whenever we are going to deal with this, so you are knowing that how many satellites are there. Our GPS module is acting at whether receiver or the transmitter. So obviously it's a receiver. Transmitter is from the satellite. So you shouldn't bother about this GPS receiver block diagram, but at least you should know exactly when you are going to use a GPS kind of a thing, how you are getting the particular signal. So the antenna is there which you are going to use to get the particular signal, right? What is the long form of a NEMA standard? So please note it down that NEMA stands for the National Marine Electronics Association. This is the name of the standard. Okay, and whenever you are going to receive any kind of a things from the satellite, how the particular data will be available to you, which kind of a technology is using, what is the lock condition. Suppose at a time 3 satellites are in a locking position, then how you are getting the particular longitude and latitude. So using the trilateralization method, this important word you should know. So what exactly I have explained this in my during the lab session also, that the suppose the 3 are the satellites are there and you are calculating the distance. Suppose you are standing somewhere at X position, then your position is near to suppose a Y satellite, then that particular is the circle is a form. Then your X position is a some Z distance from the other satellite, then another circle is formed, and then there will be the intersection. Okay, so if the third satellite comes into the picture, then again the distance is calculated and third circle is there. So like this, the 3 circles are intersecting. So if the more circles are there, you will more accurate position of that particular person we will get. So like this, the terminology of trilateralization is. Okay, so you should know at least these terminologies when we are dealing with the GPS. So this is the model everybody had used. Only the antenna is not seen over here, but you should know that the antenna is there. Okay, so the next is the GPS receiver antenna can see at least 4 satellites, and it can accurately calculate its position and time, and this is called as a lock or lock condition. Okay, so these are the message formats. I have already talked about the NEMA standard, and we are getting the series of a data sentence. Then at least at the max 40 characters are there, and the sentence starts with the GP, a dollar sign, and then you are getting the GP. GP stands for the global position. Okay, so about 80 characters, and always those characters are ended with the carriage return or the line field sequence. That is important. I will eventually show you that also. Okay,
Excuse
so
me, ma'am.
yes. Anybody is asking? You are not able to see this?
Yes, ma'am.
we
We
can't see it.
we can't see
Yes?
this.
You are not seeing the
Ma'am, the
screen?
screen is no,
Completely
ma'am.
black.
Okay, wait. Just a minute. I will check it out. From where you have not seen, dear?
Ma'am,
From
from
the starting
GPS
of
part.
GPS.
Oh God, you have not disturbed me. Okay, wait. Now,
Yes, ma'am.
is it visible?
Yes, ma'am.
Yes, ma'am.
Okay, so quickly again, I am just going through the slide. So dear, I have explained this, what exactly the global positioning system. Okay, so I have told you regarding this that no one will ask you what exactly this GPS receiver block diagram, even though it is there in my slide, or you have also seen. Very important thing, this terminology I have highlighted in my slides. that this NEMA standard is very important. Generally, though, no one has given you, I hope, up till now, the long form of it, but please, you should know that it's a National Marine Electronics Association standard. Okay, and this standard is framed so that everybody understand what exactly the framing GPGGA, GPRMC is. And I have explained this trilateralization method. Okay, so I have explained that I have explained in lab session also. So suppose 3 satellites are there and they want to you want to calculate x person's distance from these 3, then the circles are going to be formed and their intersection gives you the exact position of that x particular person position. Okay, so this is called as a trilateralization method. Okay, so this is very important, and generally we are getting a longitude latitude kind of a thing only whenever we are dealing with this GPGGA or any kind of a NEMA standard. So this is the general our GPS receiver module where the antenna is not there. I have already told you. So what is the lock condition? They will ask you lock or fix. So if the GPS receiver's antenna can see at least 4 satellites, it can accurately calculate its position and time, and it is called as lock position. Message format I was talking about. So I'm telling you that always the whichever this NEMA series is there, it has the 2 things compulsory. One is a dollar sign and the GP word. The GP stands for the global positioning system. Okay, and this prefix is a GP. Oh, fine. And the after dollar sign about the 80 characters are there, and generally the last one is the carriage return or checksum kind of a thing is available. I will eventually come to this. Okay, so if this is a GPGGA standard, then everybody should know that what exactly is over here. So it is a uh, universal timing representation 13:24. Then these are the second, like this is the terminology which is used. Then how many bits are there, that also you have to calculate, because you want to display the longitude and latitude. So the latitude is at suppose like this, then the 26 degree 51.0138, and N stands for whether it's a north, east, where these are the given, but the directions are given like this. So longitude also in a similar way. Okay, so number of satellites being tracked like this, the whole this string is has some meaning. Okay, and we are going to capture out of this only longitude and latitude in our lab session, but the string is 80 characters are there, as I have told you, and these are the different kinds of things which are available on the GPGGS string. Okay, and this last one which is after this star or the asterisk is the checksum. Okay, so it is a general error correction type of a code is there, whether the data has been correctly transmitted or not, like this. So checksum data is always there. So I have given you in detail explanation about this GPGDA string also. Okay, if you have a more, if you are interested, then I'm sharing this so that you can understand this in more detail. So parallelly with the GPGGA, if the question is asked, which are the immediately parallel to GPGGA? So immediately parallel to GPGGA, this GPRMC. It will again give you longitude, latitude, and always on a similar line it will also work. Fine. So you can use either GPGGA or GPRMC. So both are okay. Only you should know that how many characters and what exactly the strings are. So as I have stated, please read this. GPRNC is simply telling what sentence type is on the line. Okay, so here also it will give us a UTC time. Here also it will give us only whether the signal is active or not, like this. This is an additional thing over here. But next you will get a latitude and the longitude, whether it is a northern hemisphere or the east, west hemisphere, like this you will get. So on the parallel line of a GPGG, we have another standard as or another NEMA standard as a GPRMC as well. Okay, so like this we are having the different kinds of a thing. So how you are going to write the program of the GPS? Start initialization of the UART. Why do we require UART? That is my next question to all of you. Please prepare your answer in your mind. Then you are receiving this particular GPS message of location and longitude to UART module. Okay, then whichever you are receiving, you are storing in a different types of a user defined string, and then those string only we are transferring to the LCD. Like this is the algorithm for the our GPS module. Fine. So again I'm going to stop sharing this screen, and again I'm coming to all of you. So I'm unmuting all. Yes, students. So have you understood the GPS module?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Arnav, Manas? Yes,
Yes,
Neha?
Yes,
yes,
ma'am.
ma'am.
Okay. So I think now there is a no ambiguity in the GPS and the UART section. So
No,
quickly we
ma'am.
will go to the GPS programming. So now we have already seen this. So what exactly the GPS does and everything. So I'm not going to deal with the LCD. Now my question is, why do we require UART section? Anybody, please. This is a discussion section, so even though the answer is wrong, it's okay. Yes, student. Why do we require UART section? Anybody? Why do we require UART section? Yes, dear students. Who will contribute?
To display the received data.
To display the received data. Is it? But we are displaying on the LCD. I'm not asking who is going to answering or giving me the answer. I'm just discussing. Please, even though it will take a more 10 minutes, I will again just extend the meeting. But I want it should be very much clear, dear students. Yes, please contribute. Why do we require UART? Are you able to recall the interfacing diagram, or what interfacing we have done over there? So our GPS module we have connected to the UART section, right? So whichever data we are receiving it through UART, then it comes to the LPC2148, this receiver, you are going to receive it through the UART section, and then whatever we are receiving, we are going to transmitting it to LCD. Is it
LCD.
correct?
Yes.
Yes or no,
Yes,
dear
ma'am.
Yes,
students?
ma'am.
Yes.
Yes,
Yes,
ma'am.
ma'am.
So this is
Yes,
a
ma'am.
yeah, this everybody should remember. And I'm quickly going through this main program only. So because everybody knows LCD now, I have already explained you. So we are going to just see this GPGGA character, right? Once we got this, we have just defined all these strings. We know the what are the lengths of these strings. Okay, we have used pin select, UART, initialization, and everything we have done. Okay, and we are continuously doing. First we are grabbing the dollar sign, then this 5 characters GPGGA. If this is matched, then we are going to store it in one string. Okay, string 1, and then eventually we are going to grab the next 12 characters as a time data. Okay, latitude and the longitude, and then eventually we are displaying it on the LCD. Fine. So again for the LCD also we are using the same sections. LCD initialization, then LCD command, function, LCD data. Okay. So like this, the whole program is working for the GPS. Fine. So I guess the GPS program is, have you understood the things? Students?
Yes, ma'am. Yes.
So if we don't want to use GPGGA, and if we want to use GPRMC, can you do that? If there is any hurdle to do this, only you should know that where exactly the longitude and the latitude from this GPRMC section. Okay. So in many research articles, instead of GPGGA, they have used GPRMC as well whenever they have done the GPS intersection with the LPC2148 or Arduino. Okay, so instead GPGGA, instead of that, they have most popularly they have used GPRMC as well. Fine. So I hope this section is clear, and how this gate function and everything you can use in your program of the GPS. Okay. So
Yes, ma'am.
by today night, I will give you the some questionnaire on the unit number 2 and unit number 3, and eventually on the unit number 4 as well. Okay. So I guess this UART section and the GPS is very much clear to everybody, right?
Yes.
And we will meet with the next concept and the next assignment. Okay. Yes,
Ma'am,
Neha.
students are asking for this PPT.
Yeah, I will definitely share my PPTs. But does this lecture is
Okay.
work for you people? Because I want this feedback also. Is it okay that the speed is okay, dear students?
Yes, ma'am.
I don't want that I should complete in a 2 hours whole unit. I am not agree with this. It's okay, but I am focusing on your understanding it, because it's a revision session which we are going on. And please, if you have any
Yeah.
doubts, you are not asking only the doubts. So I understood that I am not understanding whether you are getting it or not. Is it clear, dear students?
Yes, ma'am.
Yes,
Okay.
ma'am.
Okay.
Yes, ma'am.
So in the next section, we will see some other assignments. I have cleared the GPS, and in coming session, GSM, I2C, or GSM, or some other modules. Let us see that how we will, how I will manage, and I will eventually give the message through Arnav. Okay. So
Okay,
should
ma'am.
I
Yes,
end the
ma'am.
meeting now?
Okay.
Yes, ma'am.
Okay. Thank you so much, dear students. Please stay safe.
Thank
Okay.
you so much, ma'am.
Thank you,
Thank you all
ma'am.
of you for attending the
Thank
session.
you.
Please take it very positively, all these revised session. I'm specially coming for you people, so that you can understand and you are revising the things properly. Okay.
Yes. Yes, ma'am.
Okay.
And especially T7.
Yes,
Okay.
ma'am.
So thank
Yes.
you so much. Arnav, please try to collect the feedback from the student, what they are expecting more and all. Okay, Neha,
Yes, ma'am. Sure,
Malli,
sure.
I'm not getting Khandekar is there or not? Huh?
No.
No?
No, ma'am.
Okay, you tell him that madam is just asking about you.
Yes, ma'am. Sure.
Okay, thank you so much. Chalo, bye.
Thank you, ma'am.
Okay.
Thank you, ma'am.
Thank you.